So, it really feels like we're living in the future, right? The pace of technological change isn't just fast anymore, it's relentless. Every time you blink, there's a new breakthrough, a new acronym, a new device that promises to change everything. And what's interesting is, it's not just hype. We're seeing paradigm-shifting technologies like artificial intelligence, 5G, and blockchain move from abstract concepts in a lab to tangible tools that are already reshaping entire industries and weaving themselves into the fabric of our daily lives. It's a lot to keep up with, and it can feel overwhelming trying to separate the signal from the noise. That's why we're doing this. We're going to break it all down. In this video, we'll cover the 20 most important technology trends that are defining the future and changing how we live, work, and do business. Think of this as your roadmap to what's next, a guide to the innovations that are fundamentally altering our world. From the way our cities are managed to the entertainment we consume, the impact is massive, and it's happening right now. So you're definitely going to want to stick around for this one. We're not just listing trends, we're digging into what's really driving these shifts, what the real-world applications look like, and what it all means for you. We'll explore the incredible potential and, just as importantly, the real challenges and ethical questions that come with it. From healthcare and finance to gaming and manufacturing, these trends are the building blocks of tomorrow. Let's get into it. Alright, let's start with the big one. Artificial intelligence and machine learning. You hear these terms everywhere, and for good reason. At its core, this is all about creating systems that can learn from data, identify patterns, and make decisions with minimal human intervention. It's the engine behind your Netflix recommendations, the voice assistant on your phone, and the fraud detection that protects your bank account. It's becoming this foundational layer across nearly every industry, from optimizing logistics and shipping to diagnosing diseases in healthcare with a level of accuracy that was unthinkable just a decade ago. It's fundamentally changing the capabilities of our machines. But of course, it's not all smooth sailing. The conversation around AI is also a conversation about its challenges. The most obvious one is job automation. As machines get smarter at performing routine tasks, both blue-collar and white-collar, we have to ask what that means for the workforce. Then there's the critical issue of bias. If an AI is trained on biased data, it will produce biased results, which has serious implications for everything from loan applications to criminal justice. Nailing the ethics and governance of AI is just as important as developing the tech itself. Next up is 5G. For years, it felt like this thing the carriers were just talking about, but now it's actually here, and it's a massive leap forward. It's not just about your phone loading videos faster, though it is really fast. The real game changer with 5G is its combination of three things: massive bandwidth, incredibly low latency, and the ability to connect a huge number of devices simultaneously. This trifecta is what unlocks the next wave of innovation. It's the connectivity backbone that will power truly smart cities, with traffic lights, vehicles, and infrastructure all communicating in real time. This is the technology that makes things like remote surgery, which requires a zero-lag connection, a real possibility. It's what allows the Internet of Things to scale from a few smart devices in your home to billions of sensors in a factory or across a farm. However, the rollout is a huge undertaking. Building out the necessary infrastructure of small cells and towers is expensive and time-consuming, and achieving consistent widespread coverage, especially outside of major urban centers, remains a significant hurdle. So while the potential is enormous, we're still in the early innings of the 5G era. So, that brings us perfectly to the Internet of Things, or IoT. This is the concept of taking all the physical objects in our world, from a smartwatch to a jet engine, and connecting them to the internet. Essentially, we're giving the physical world a digital nervous system. In your home, it's your smart thermostat learning your schedule. In healthcare, it's wearable sensors that monitor a patient's vital signs and alert a doctor before a crisis happens. In manufacturing, it's sensors on machinery that predict maintenance needs, preventing costly downtime. It's all about gathering data from the real world to drive efficiency and smarter decisions. The potential for optimization is just staggering. But when you connect everything, you also create new vulnerabilities. Security is the single biggest challenge for IoT. Every single connected device, from a smart coffee maker to a city's power grid controller, becomes a potential entry point for a cyber attack. Ensuring that these billions of devices are secure, that the data they collect is private, and that they can't be hijacked is a monumental task. As we embed this technology deeper into our critical infrastructure, the stakes get incredibly high. This one might sound a bit technical, but it's super important: edge computing. Traditionally, when a device needed to do some heavy processing, it would send data to a centralized cloud server, wait for the cloud to do the work, and then get the result back. That round trip takes time, and that delay is called latency. Edge computing flips that model on its head. Instead of sending data far away, it processes the data right there on the device itself, or on a small local server nearby, right at the edge of the network. This drastically reduces latency. Think about a self-driving car. It needs to make a split-second decision to brake. It can't afford to send camera footage to the cloud and wait for instructions. That decision has to happen instantly, and that's what edge computing enables. It's also crucial for things like facial recognition for security access, real-time analytics on a factory floor, or AR glasses that need to overlay digital information onto your view of the world without any lag. It's becoming the standard for any application where speed is absolutely critical. Okay, when most people hear blockchain, they immediately think of Bitcoin and cryptocurrencies, and that's where it started. But the underlying technology has potential that goes so much further. At its heart, a blockchain is a distributed, immutable digital ledger. Distributed means it's not stored in one central place, it's copied and spread across a network of computers. Immutable means that once a transaction is recorded, it can't be altered or deleted. This creates an incredible level of security and transparency without needing a central authority like a bank or government to verify things. This is a huge deal for more than just finance. Imagine a supply chain where you can track a head of lettuce from the farm to the grocery store with every step securely recorded on a blockchain, ensuring it's fresh and safe. Or using it to manage medical records, giving patients full control over their data and who can see it. It could be used for secure voting systems, managing intellectual property rights, or verifying academic credentials. It's about creating trust in digital systems, though challenges like scalability, energy consumption, and regulation still need to be fully worked out. AR and VR. These are two sides of the same coin, both focused on creating more immersive digital experiences. VR, or virtual reality, completely replaces your surroundings with a digital world. You put on a headset and you're transported somewhere else. A fantasy world for a game, a virtual meeting room, or a three-dimensional model of a building a client wants to see. It's about total immersion. AR, or augmented reality, is different. It doesn't replace your world. It overlays digital information on top of it. Think Pokemon Go, or an app that lets you see how a new couch would look in your living room before you buy it. The applications are expanding way beyond just gaming. In education, medical students can practice surgery in a risk-free VR environment. In manufacturing, an AR headset can guide a technician through a complex repair step by step. Real estate agents can give virtual tours of properties to clients on the other side of the world. But the hardware is still a barrier. VR headsets can be expensive and bulky, and creating truly convincing, comfortable, all-day AR glasses is one of the toughest hardware challenges out there right now. Now we're getting into the really mind-bending stuff: quantum computing. This is a fundamentally different way of processing information. Your classical computer, the one on your desk or in your pocket, works with bits, which can either be a 0 or a 1. Quantum computers use qubits, which can be a 0, a 1, or both at the same time, thanks to a principle called superposition. This, along with another quantum phenomenon called entanglement, allows them to process a massive number of possibilities at once. They're not going to replace your laptop for browsing the web. Instead, they are designed to solve very specific, incredibly complex problems that are practically impossible for even the most powerful supercomputers today. We're talking about discovering new materials and medicines by simulating molecules at the quantum level, creating new financial models to manage risk, or breaking modern encryption, which is also why they're a huge focus for national security. But we have to be clear, this technology is very much in its infancy. Quantum computers are still large, fragile, and extremely difficult to build and maintain. We're still years, maybe decades away from them having a widespread impact. Robotic process automation, or RPA, isn't about physical walking around robots. It's about software bots that are programmed to automate repetitive, rule-based digital tasks. Think about the boring, tedious stuff that someone might do at a computer all day. Copying and pasting data from a spreadsheet into an enterprise system, processing invoices, filling out forms, or responding to simple customer service queries. RPA is designed to take over those tasks. It's like having a digital assistant that can work 24/7 without getting tired or making typos. The main goal here is to improve efficiency and accuracy, and more importantly, to free up human employees from mundane work. This allows people to focus on more creative, strategic, and complex problem solving, the things humans are uniquely good at. It lets a company scale its operations without necessarily scaling its headcount in the same way. The challenge, of course, is that implementing RPA requires a significant upfront investment in software and development, and it requires carefully mapping out business processes to figure out what can and should be automated. As every part of our lives becomes more digital and connected, the attack surface for bad actors gets bigger. That's why cybersecurity is not just a trend, it's a constant, evolving arms race. The threats are getting more sophisticated every day, from AI-powered phishing attacks to ransomware that can cripple a hospital or a city government. So, our defenses have to get smarter too. We're moving beyond traditional firewalls and antivirus software to more proactive and intelligent security measures. This includes using AI and machine learning to analyze network traffic in real time, detecting anomalies that could signal an attack before a human could ever spot it. There's also a big shift towards a zero-trust security model, which basically operates on the principle of never trust, always verify. It means every user and every device has to be authenticated and authorized before accessing any part of the network, even if they're already inside the perimeter. The challenge is that there's no silver bullet. It requires constant innovation, vigilance, and investment to stay one step ahead of the attackers. Technology has, historically been a huge consumer of energy and resources, but now there's a massive push to use technology to solve environmental problems. This is the world of sustainable technology, or green tech. It's a really broad category that covers everything from renewable energy sources like next-generation solar panels and wind turbines, to developing new materials that are biodegradable or just easier to recycle. It's about finding smarter, more efficient ways to do things. We're seeing this in smart grids that optimize energy distribution to reduce waste, precision agriculture that uses sensors and drones to cut down on water and pesticide use, and the development of a circular economy where products are designed from the very beginning to be reused, repaired, and recycled. The goal is to decouple economic growth from environmental degradation. The biggest hurdles right now are scalability and cost. While a new green technology might work great in a lab, scaling it up to industrial levels and making it economically competitive with existing, less sustainable methods is a huge challenge that really requires massive investment and policy support. This is where things start to feel like science fiction, but honestly, it's happening now. Human augmentation. This trend is all about using technology to enhance our natural human abilities, both physically and cognitively. On the physical side, you have things like advanced prosthetics that can actually be controlled by a person's thoughts, or industrial exoskeletons that let a factory worker lift heavy objects without any strain. Wearable devices that monitor our health are already a mainstream form of this, giving us insights into our bodies we never really had before. On the cognitive side, it gets even more interesting. We're seeing the early stages of brain-computer interfaces, or BCIs, which aim to create a direct communication pathway between the brain and a computer. The initial applications are medical, helping people with paralysis control a robotic arm or communicate. But honestly, the long-term vision for some is to augment human intelligence itself. Of course, this raises profound ethical and privacy questions. Where do we draw the line? What does it mean to be human when we can be technologically enhanced? And who actually gets access to these enhancements? For anyone who writes code, this trend is, honestly, a massive deal. AI augmented development is about using artificial intelligence and machine learning to assist in the software development lifecycle. Think of it as giving developers a super intelligent pair programmer. AI tools can now automatically suggest lines or even entire blocks of code, which speeds up the process immensely. They can analyze existing code to find bugs, security vulnerabilities, or inefficiencies that a human might just miss. It's really changing how software is built from the ground up. These AI tools can also automate the testing process, running thousands of simulations to make sure an application is robust before it's released. This not only accelerates development timelines but can also improve the quality and security of the final product. The idea isn't to replace human developers, but to augment their skills, handling the repetitive and time-consuming parts of the job so they can focus on architecture and creative problem-solving. The caution here is that developers still need to understand and validate the AI's suggestions, since these tools can sometimes introduce subtle errors or security flaws if used without oversight. Cloud computing isn't really new, but, the way it's being deployed is definitely changing. We're now seeing the rise of industry cloud platforms. Instead of that one-size-fits-all cloud solution from a provider like Amazon, Google, or Microsoft, these are cloud platforms that are specifically tailored and pre-configured for the needs of a particular industry, like healthcare, manufacturing, or financial services. They come with a suite of tools, data models, and APIs that are designed for that industry's specific workflows and processes. For example, a healthcare cloud platform would come with tools that are already compliant with patient data privacy regulations like HIPAA, and would have connectors for common medical imaging systems. A manufacturing cloud might have built-in tools for supply chain management and IoT data from factory machines. This approach really helps companies accelerate their digital transformation because they're not starting from scratch. They get a solution that already speaks their language. Of course, the challenge remains security and preventing vendor lock-in, making sure that critical industry data is both protected and portable. We've had apps on our phones for over a decade, but now, we're entering the era of smart apps. These aren't just static programs that perform a function. They're dynamic, adaptive applications that use AI and machine learning to deliver highly personalized and predictive experiences. Your navigation app that reroutes you around traffic before you even know there's a jam? That's a smart app. The email client that automatically sorts your messages into priority inboxes and suggests replies? Yeah, that's a smart app too. They learn from your behavior and the context around you. These applications are really designed to be more like personal assistants, automating multi-step tasks and anticipating your needs. For example, a smart travel app might not just book your flight, but also check you in automatically, monitor for delays, and book a car to the airport at the right time. The goal here is to make our interactions with technology more seamless, efficient, and intuitive. The big trade-off, as always, is data privacy. For an app to be this smart and personalized, it needs access to a huge amount of your data, and users need to be confident that this data is being used responsibly and kept secure. If you've played around with tools like ChatGPT, Midjourney, or DALL-E, you've experienced this trend firsthand. Democratized Generative AI. For a long time, the ability to create AI that could generate new, original content, be it text, images, music, or code, was limited to just a few massive tech companies with huge research labs. Now, through APIs and user-friendly interfaces, these incredibly powerful tools are accessible to almost anyone. This is a massive shift, putting the power of content creation into the hands of millions. It's democratizing creativity and productivity in a way we've honestly never seen before. A small business owner can generate marketing copy and social media images in seconds. A student can get help structuring an essay. A developer can prototype an idea by having the AI generate the boilerplate code. The potential here is enormous, but it also opens a Pandora's box of challenges. There are major questions around copyright and ownership of AI-generated content, the potential for misuse in creating misinformation or deepfakes, and the impact it's going to have on creative professions. Navigating this new landscape is a major challenge for society. This is another deep-cut cybersecurity trend, but honestly, it's a critical one for any large organization. It's called Continuous Threat Exposure Countermeasure, or CTE. So, traditional security often involves periodic vulnerability scans, maybe once a week or, once a month, to find weaknesses. The problem is that a lot can change in a day, let alone a month. A new vulnerability could be discovered, or a developer could accidentally misconfigure a server, leaving a door wide open for attackers. CTE is about shifting from periodic scans to a continuous, real-time approach. CTE systems are constantly monitoring an organization's entire digital footprint, both internal systems and external-facing assets, to identify and prioritize vulnerabilities as they emerge. It's about seeing your own network through the eyes of an attacker 24/7. This allows security teams to move from a reactive posture, patching after an attack, to a proactive one, fixing the weakness before it can be exploited. The challenge is that these systems can be resource-intensive and generate a lot of data, so teams need effective ways to filter the noise and focus on the most critical threats first. As we rely more and more on AI for critical decisions, we really need to be able to trust it. That's where AI trust, risk, and security management, or AI TRiSM, comes in. It's not a single technology, but a framework of governance and tools to ensure that AI models are reliable, fair, transparent, and secure. It's about managing the entire life cycle of an AI model, from the data it's trained on to the decisions it makes in the real world. This is the practical application of AI ethics. AI TRiSM addresses key questions. How do we ensure the training data isn't biased? How can we explain why an AI model made a particular decision? Explainability. How do we protect the model itself from being tampered with or attacked? Model security. And how do we ensure the AI's decisions are fair and accountable? It involves implementing tools for model monitoring, data validation, and explainability to build trust among users, customers, and regulators. This is becoming essential for any organization deploying AI in high-stakes areas like finance, healthcare, or human resources. This is a trend that's transforming how software development teams operate in large organizations. It's called platform engineering. As companies adopt more complex technologies like cloud-native architectures, microservices, and DevOps, developers can get bogged down dealing with all the underlying infrastructure and tooling. They end up spending more time on configuration and plumbing than on actually writing the code that delivers value to the customer. Platform engineering aims to solve this problem by creating a dedicated internal platform. Think of it as creating a smooth, paved road for developers to drive on. A dedicated platform engineering team builds and maintains a set of standardized, self-service tools and workflows for things like setting up new environments, deploying code, and monitoring applications. This allows developers to be much more productive and self-sufficient, as they can access the resources they need on demand without having to be infrastructure experts. It's a significant investment to build this kind of internal platform, but for large companies, it can drastically accelerate the pace of software delivery and innovation. This one is a bit out there, but it's on the horizon. Machine customers, sometimes called custobots. This is the idea of AI systems or smart devices that act as autonomous economic agents, making purchasing decisions on behalf of a human or a business. We already see very basic versions of this, like a printer that automatically orders new ink when it's running low, or a smart fridge that could add milk to your online grocery order. But the concept goes much further. Imagine a factory's AI management system that not only monitors its machinery, but also autonomously negotiates with suppliers, compares prices, and orders replacement parts to get the best deal and ensure no downtime. Or a personal AI assistant that manages your subscriptions, finds you better deals on insurance or cell phone plans, and even switches providers for you automatically to save you money. It's the ultimate evolution of automation, focused on consumption. This could create hyper-efficient markets, but it also raises huge questions about accountability, security, and the potential for manipulation if these bots can be hacked or influenced. Finally, let's talk about the future of work itself, with the augmented connected workforce. This is about more than just Zoom calls. It's the convergence of several trends to create a more intelligent, flexible, and productive work environment, whether people are in the office or remote. It involves using digital collaboration tools that are smarter and more integrated, creating a seamless flow of information regardless of physical location. It's about building a digital headquarters that is as important as the physical one. This is augmented by AI providing real-time insights to employees, helping them make better decisions. Think of a sales representative getting live suggestions during a client call, or an engineer receiving data-driven insights about a design flaw. It also includes the use of wearables, like AR glasses for remote assistance, which we talked about earlier. The goal is to empower employees with the right information and tools at the right time. The main considerations are ensuring this technology actually improves employee well-being and doesn't just become a tool for surveillance, which brings up critical privacy and data handling questions. So there you have it, the 20 game-changing technology trends shaping the future as we speak. From the foundational power of AI and 5G to the mind-bending potential of quantum computing and human augmentation, it's clear we're in a period of incredible transformation. These aren't just isolated trends, they're interconnected pieces of a larger puzzle, each one enabling and accelerating the others. Understanding them is key to understanding where our world is headed, and the opportunities and challenges that lie ahead. The pace isn't slowing down, so the conversation doesn't stop here. We've covered a lot of ground, and I'm really curious to know what you think. If you've made it this far, let us know what you think in the comments section below. Which of these trends are you most excited about? Which ones are you most concerned about? Is there anything massive that you think we missed? Let's get the discussion going. Your engagement really helps the channel, so if you found this breakdown valuable, a like would be amazing. And for more interesting topics and deep dives into the tech that shapes our world, make sure to watch the recommended video that you see on the screen right now. Subscribe if you haven't already so you don't miss what's next. Thanks for watching.